Welcome back to Mackey's Motors. For my PM students and anybody following along doing basic electric, today we're learning electrical testing, and the first test we're going to talk about is resistance. Something that is blocking our path or flow of electricity. It is measured in something called ohms, and we use the omega sign. So you need a multimeter, voltmeter, DVOM is what we refer to them in the auto mechanic world. And once you have your lead set proper and you have your meter set proper, you can start right away by trying to find any resistance. The most important thing to know is what you're reading. A good reading is having any type of number, a small number, if you're looking for a good wire. Now, I've seen it say open lead, OL, on the meter. That may mean you have a broken wire somewhere. You want to have at least a very, very minimal, very, very tiny number. But if you have a high number, that means there's high resistance. Not necessarily a bad thing depending on what you're looking for. If we're going to measure a light bulb, which I'll show you later, then you're going to want a number. You're going to want a pretty high number because there's a filament inside there that is a resistor. It generates heat, it stops the flow of electricity to light up that element. So you're going to want a higher number on there. But if you're measuring a wiring harness and you want to see if you have a broken wire or if you have corrosion in your harness, then you don't want to see OL and you don't want to see a high number. You want a nice, fine, small, very, very, very low number. So we're going to do some electrical tests today. I've got a couple of wires that are cut. I damaged a wire intentionally. I have a couple of crimped on connectors to show you how to determine if your crimp is good or not. And we're going to get into using the meter and testing it out. So follow along and hopefully you can learn something today on resistance. So for starters, we have our meter set up. I make sure that my leads are in the proper place. And to do that, you got to read the bottom. The little graphics here, icons. If I hold the meter up and bring it to you, you'll see that my leads are connected to the positive, which is my red wire, volts, ohms, hertz, and a diode check. And then my black is connected to the common. So, once the leads are connected properly, you find the proper location on the dial. You got to find the omega sign. That is ohms. So, we're going to turn it on. And we're going to get a reading. OL means open leads, which means we're not reading anything. So I'm going to put this down so hopefully you can see it. Can you see my numbers? Okay. And we're going to start testing a couple of wires that I brought. So let's back this out a little. So the first wire I have here just a standard piece of 14 gauge. How do I know it's 14 gauge? Because it's got the number 14 and it says gauge. It's fairly thick for a small wire. And what I'm going to do is I'm going to connect both of my leads, one on each end, and we're going to see what reading we get out of it. So I'm just going to hold that there. I'm going to hold this end here, and we're going to see what it reads. Nice, very low number. Awesome. So let's do a comparison. This wire I intentionally damaged. It's got a couple crimps in it, kinks, and let's see if we can get a measurement. Whoa! Can you see that? We got some high numbers there. Now if I wiggle the wire, it goes all over the place. That wire has a lot of resistance in it. I think that wire is damaged. That's a lot of resistance. So, you can see that, like I said, I got some crimps and kinks in it. So this wire would be damaged. If you found something like this in a harness, it could have been from somebody crimping and cutting and it's a bad connection, or it could have been when somebody puts something back together, they pinch the wire in a panel or something. Always visually inspect your wires and look for the obvious. Look for obvious signs. This wire is flattened where I crimped it. I sat here bending it and tweaking it so that I can make sure I get a bad reading for you guys. I actually can hear it cracking inside from the wire splitting apart. And you saw how high the numbers went up on the meter. There is a lot of resistance being generated in there. If I was diagnosing something and I tested one wire and got that super low reading, and then I tested the next wire and got those really high readings, right away I got bells and whistles going off that there's damage in that wire or something happened. So, next up we're going to try these two connectors. So this is a crimp-on connector right here. I'm going to put one of the leads on the crimp connector here, the eyelet. And I'm going to put the lead on the other end. And we've got resistance. So right away I would suspect some resistance in here because I've added a connector to a straight wire. But that number seems a little high to me. So let's try this other one. Put that on there. And that is a really, really low number. So, in testing these two harnesses real quick, this one is really, really solid and pretty steady. And this one was all over the place, wasn't it? That's some high numbers. So what would cause that? Well, let me just wiggle the wire. Look at that. Goes from a really good connection to no connection to a ton of resistance just by bending the wire. So that would lead me to believe right away that this connection is no good. I would have to rip this off and start over. So, look at that. I even have corrosion inside the terminal here, and I just ripped it right out. So, when you're trying to diagnose any type of wiring issue, if you have something that is not working properly, something that's functioning slower than it used to, right away you can do a resistance test on the wiring and you can determine if there is a fault in the wiring. Now, if all of your readings come up really, really nice, like this one did, very, very low numbers, very steady, then chances are the wiring is good and you can go after something else. It could be faulty components, it could be anything other than the wire. But being able to read resistance and being able to understand what it means, then you would know right away what you're targeting. You can eliminate components, you can eliminate the harness, you can eliminate the guesswork, because a lot of people, when they tackle electricity, they think they have to try everything. But a very, very basic resistance test on some harnesses, you can eliminate stuff right away. You can narrow it down from a switch to a motor or to a simple poor crimp connection. So that is a basic resistance test. Now the other test I have for you is determining if a light bulb is good or bad. So a lot of people, when their light goes out, they right away go and replace the light bulb. And sometimes it works, sometimes it doesn't. How do you know if a light bulb is good or bad? Well, all light bulbs, bing, have a filament inside. There's a little wire, a little coil inside this light bulb that it lights up when it receives electricity. It is a resistor. So if I were to take my meter and I have it set to ohms, I want to measure if it has resistance. So I'm going to take my negative lead and touch it to the body of the light bulb. And I'm going to take my positive lead and touch it to the contact on the bottom of the bulb. And I should get a reading. There you go. There's my resistance. That means that this filament is intact and it is working properly. Now, the fact that I have resistance, I just confused everybody. I thought you don't want resistance. I thought you want electricity to pass through. The answer is no. When we're testing a component that's supposed to have resistance, we want to make sure we have a steady number and we want to make sure that the number's within range. You can actually look up, there's charts for specific bulbs on what the resistance should be. Now, if it said OL like it says right now, right there, then that means that the filament broke, and it's an open circuit. It's no longer reading any resistance. The whole point of that filament is in there is to act as a resistor and generate resistance to light this thing up and get it red hot, and that's what makes a light bulb work. So a resistance test could be used for good to determine if the proper resistance is there, or if you're trying to find out when no resistance should be there, do you have resistance? So. Alright, so Mackey's Motors would like to give a special thank you. In case you haven't noticed, for my videos, I've been wearing my Newark Fire Department sweater. I have a special guest here. This is my twin brother, Rich Mackey. He is a captain in the Newark Fire Department, and it was really awesome for him to drop by today, and I just wanted to extend my thank you from Mackey's Motors to our essential personnel, our lifesavers, and the people that keep us safe during this whole entire epidemic. And thank you very, very much, twin bro.
Thanks for having me.
I'm sure all my viewers and anybody watching, thanks you also, and everybody else that's in your shoes helping us out.
Thank you, everybody. Just a couple recommendations. Make sure if you do have to go anywhere, and I stress have to go anywhere, if you don't have to be somewhere, don't go. It's as hard as it is. Everybody's going nuts because we've all been cooped up for so long. But I got to tell you, the more people stay away from each other, the better off we are. The less people getting sick makes it easier on the hospitals and the healthcare workers, because don't forget, they have families to go home to as well. Social distancing is key. It is important. As crappy as it may be, it's the one thing that's helping people. He and I can both speak from experience. Our grandmother is very elderly. I've seen my grandmother from about 25 feet away. I'm afraid to go near her because I don't know what I'm exposed to. And it's super important to me to make sure that she is safe and healthy. And it's my responsibility to stay away from her. As much as I love her and as much as I cherish every minute we have with her, I don't want to be that reason that she gets sick and won't be here anymore. So I can't stress that enough to everyone. As far as thanking us essential personnel, we all have jobs to do. I am truly thankful. Not only is my twin brother a teacher, but so is my wife. And we have 2 young children. And I know what a chore it is to try to be a parent and a teacher at the same time. My kids are 9 years old and 6 years old. So them going to school takes a lot more than just turning on a computer and saying, here's school. So my wife has students to teach, plus our own children. So my heart goes out to any of those parents, kids who are in the same position. You may have siblings, younger siblings that you have to kind of help your parents out with. We get it. So please stay safe, stay healthy. Thanks for having me. I hope you're learning a lot from Mr. Mackey.
Thanks, bro.
Thank you. Now go wash your hands.